Common Funds for Commodity, Netherlands. And we have established one pilot plant at Nagpur, which is producing the particle boards from the cotton stock. And the room, which is actually laminated completely with the cotton stock, is also visible here. We can make the very good furnitures, and all the BIS standards, that is 3087-1985, is confirming. Our product is confirming with this BIS standards. So very good. This is initiative. So people are getting, farmers are getting some additional remuneration out of that. Secondly, these are some of the photographs. We are also involved in very large scale awareness programs, because our interest is that the technology should not be remain in the laboratory or not within the institute. It should be percolated to not even in our country, but it should also go to the African countries. So we are also having work with the collaboration with the African countries regarding to this kind of technology. So now actually composting, because composting in rural areas is now very in crunch. We are farmers are not getting the compost, farmyard manure. So we have developed one culture, microbial culture. You just spray on it, and within 10 to 15 days, you will get the very good compost out of cotton stock, having the NPK content almost double than the farmyard manure. So also one of the important limitation for use of cottonseed cake in non-ruminant animals like poultry and fish is the content of the gossypol. So our scientists have developed technology which can reduce the free gossypol content up to 80% and bound gossypol up to 60%, and reduce the crude fiber 30%, and there is an improvement in protein content up to 40%, and improvement in lysine content is 25%. So now ruminant animals like fish, poultry, pig, this kind of feed can be used, and it is a cheaper source of the protein as well as the lysine. So now this is very good now, because in poultry and fish the cost of the feed is almost constitute about 70%. So if you give the, and there is no alternative, cheaper alternative for this feed. So we have developed, our scientists have developed some technology, and it has been licensed, and now it is available in the market also. Because gossypol is actually limiting factor, I think you all people know. Then also we are being a cotton institute, we are having a very strong team of scientists working on the making the composites, that to biocomposites and molded products. Because our one of the important aspect to help our farmers, not only industry but also farmers. So whatever available lignocellulosic waste from the any like cotton stock or even coir, even banana. So our mandate is to make the best use of that waste material, and we have to develop wealth from that waste. So these are the products we have developed. You can see the this our my video conferencing is laminated with the banana fiber composite boards, and with our own binding agent. We have developed our own binding agent. We are not using urea formaldehyde. Urea formaldehyde is not environmental friendly binder nowadays. So we have developed our own binder, which has been used in making the boards, and we have demonstrated. Even our DG's room is also laminated with our particle board as well as these laminates. Apart from that, we have developed some trays, nursery trays also for the biodegradable. They are biodegradable. At present, not of plastic being used for trays in the nursery business. So we are collaborated with the one of ICAR Institute, that is Floriculture Institute at Pune, and we have successfully tried. And one entrepreneur, that is Sandeep Nikam, is now manufacturing such kind of products, and we are in the process of giving the licenses in many other startups. So apart from that, we are also working in a very good area, that is preparation of specialty grade pulp from cotton linters for production of high-end security paper. So you know the currency grade paper is being actually imported some years back. But we have, our scientists have developed one technology which is our own, and that's some 10% banana fibers and 90% cotton fibers. We have developed some technology which can give the paper it is far better than the at present currency paper available in the market. Our double fold strength, which is the major characteristics for finding out the quality, our double fold test is around 8,000 double fold, and the available note double fold is around 5,000. So our paper is far better than that, but there are some limitations in transferring this technology. However, we are going for the now specialty paper like security paper, that is bond papers. Now we are very soon will be transferring this technology to the other companies. So secondly, natural fiber reinforced rubber nursery pots. So what rubber pots you are seeing, it also contains cotton fibers. So it gives the act as a reinforcement to the rubber. And rubber, because now tire sector, these synthetic rubbers have been used. Some synthetic materials have been used making the rubber tires. So there is a little bit downside market for the selling of the rubber. So we have given someone alternative, so one can make a very good pots with the help of our cotton fibers as a reinforcement. And this also technology have been successfully transferred to Rubber Engineers Thrissur, Kerala. So most of the technologies we have transferred to the industry, and the startups are already working on that, and he is now doing a very good business. And he will now be starting the exporting this good nursery plots to other countries also. So now nanotechnology in agriculture. So actually my one of scientists also waiting here, he will give more about the nanotechnology because he is the expert in this. But I could say one thing about this. This is a unique plant we have established in our Mumbai, and that is first in India, and fifth in the world. So our scientists have actually indigenously designed this layout. Then indigenously machinery have been used, except one or two machinery we have imported. Otherwise, this pilot plant was very successfully running, and since 5 years we are continuously running and giving nanocellulose and other nanoparticles to various industries. We are selling to this, and we have signed a very good one memorandum of understanding with the Rashtriya Chemicals and Fertilizers for the nano zinc combination, because the zinc is actually very important in found to be very important in the improvement in the yield. So if you give in a nano form, it is yield has been increased almost 3 times. So apart from that, nano zinc based antimicrobial products also we have developed, because now health, the health sector, that contamination in the hospitals, then even railways, there are many people do come, and there is a cross infection always there. So we have developed this nano zinc because nano zinc is antimicrobial property. It inhibits, it gives the fabric. So we have developed some technology in nano zinc oxide based antimicrobial products, and we have also one manufacturer, that is Green Globe, is manufacturing this kind of bed sheets and hospital wears. And next is the also this wound dressing. Actually, if you go to the market, you will get the wound dressing of very synthetic in nature, and that is most of these are imported. And so we have concentrated on this use of cotton in the wound dressing material. So our scientists in our institute have developed the high performance cotton pads for wound dressing with the technology developed by our institute. And that is also tested in a hospital, very big hospital, that is the Sion Hospital. And one incubator is also came forward, and he will be manufacturing soon in India. So also we have natural fiber based well-being air freshener packets, in which mosquito repellency can be incorporated, or other good fragrances can be incorporated. And one incubator is also manufacturing such kind of well-being air fresheners. And very soon we will be more and more people will be coming forward for this, taking this technology. Apart from that, smart textiles also we are working on this area, cotton based smart heating gloves and garments. And almost the temperature, we can increase the temperature up to 45 degrees centigrade. And even our small battery charger can be used, and for this, and it will work for almost 6 hours, and a very simple one. And the advanced version is in pipeline, so very soon we are coming out with this kind of technology, which can be used by the people who are staying in the cold areas. So apart from that, actually our institute is empowered with the Bombay Stock Exchange for testing their samples, actually, which we call as the Clearing Corporation of India. We are paneled as approved assessor with the Indian Clearing Corporation for quality testing, and we are getting good revenue out of that. Apart from that, you can see the calibration cotton. Calibration cotton is a standard reference material for calibration of the cotton testing equipments, and I am very proud to say that in whole world we are the only institute. Hello, hello.
Yes, sir, you're completely audible.
No? Okay. So our institute is the number one in the world. I think only one in the world who is giving the calibration cotton as a reference material in ICC mode as well as the HVI mode. And the second institute is the USDA, United States Department of Agriculture. They are going only for HVI mode. So in the whole world, almost 80 countries are actually growing cotton, and among that, these two institutions are only making the calibration cotton and delivering to the machinery manufacturers for calibration of their equipment. Every day we have to calibrate the equipment for the accuracy. So this kind of program is going on in our institute, and we are very proud that we are associated with this. So now cotton byproducts and biomass. There are very long value chain of cotton. It is not like other food commodity. It is very big. After harvesting, cotton has to be gin, means separation of the fiber. Then 1/3 is the fiber. Then we have to go for spinning. You can make a yarn. After yarn, you have to weave it. Then you will get the fabric. Then there is a chemical processing, which scouring, bleaching, dyeing, finishing operations do come, and ultimately garmenting. So this is a very so many unit operations, and every unit operation is one industry. So, and you will get the 2/3 of weight by as a cotton seed. From cotton seed contains around 18% oil, edible oil, and which can extract up to 11% we can extract by the screw presses. And apart from that, we will getting the linter, then hulls, cotton seed, mean as a byproducts. So this is also one complete value chain, is another value chain. Second is, I already told, particle boards, briquette, pellet, composting. So it is like a kalpavruksha. Not a single part of the cotton is being wasted. So it has a tremendous scope in that. And for your information, if you take 4.5 kilograms of seed cotton, you will get around 1.5 kilogram of lint. And from 1.5 kilogram, that is dead kilo, you can make 2 shirts. You can make out of that 1.5 kilogram. You can make 2 pants, 2 shirts, 1 towel, 2 bunions, and 1 handkerchief. So its value from around 1.5 kg lint costing around 250 rupees, and the final value added price of these 9 products is around more than 6,000 rupees. So almost 18 to 20 times value addition is there in this sector. Apart from in cotton seed also it is like that. So it is that's why it has a very tremendous potential in this area, and it is a very important cash crop of this country since immemorial. And almost there is and as you know, for human being, almost whenever it is existing, the cotton and other fabric will be required by these human beings. So apart from that, this is a simple example. If you have a 29 millimeter staple length of cotton, you can make the 160 shirts from the 100 kg of seed cotton, means 33 kg of fiber. You can make the 160 shirts. If the staple length is more, suppose 34 to 36 millimeter, from the same 100 kilogram of seed cotton, you will get the 33 kilogram of fibers, and from 33 kilogram of fibers, you can make the 225 shirts. So 225 shirts, if you consider it is a 1,000 rupees a cotton shirt, so almost 2,25,000 rupees value addition is there. So it is a tremendous value addition in cotton fiber. Then we have also helping the budding entrepreneurs, startups by the two programs, that is Ankur and Uday, and so many entrepreneurs we have handholded and given the government of India as a subsidy for that. And now it has just started from last year, so very good response for this scheme. So almost you can see the 144 lakh rupees we have spent on this. We have distributed to our incubators just last fortnight. So this is actually very good product our scientists have come developed. That is a cotton blended garment as athleisure. Means in sports also, in young generation requires the garment which can be used as a leisure wear, it can be used as a sports wear. So we have developed this fabric with cotton and lycra brand, having very good properties, which is comfort properties as well as the moisture wicking properties. It absorbs moisture from skin and transports it to the outer surface. Then we have, it gives a very lasting colors. And we have infused, that is, this is also use of nanotechnology here we have incorporated, that is a silver infused, which gives the anti-odor property as well as the anti-macro property. Also it quick drying, and lycra blend gives the dimensional stability, and it is very importantly that is UPF factor, that is 50 plus, which is a UV resistance, and it is very good. All the UV rays, almost 99% UV rays are blocked. It cannot reach our skin. So this is also product we have developed, and one incubator, that is Green Navi Mumbai, have manufacturing this, and it is available on Amazon also. So this is again, we are also working on the color cotton. So it is a naturally colored cotton. In the nature, even we do not know, we are only aware of that cotton is of white color. But in the nature, cotton is available in khaki color, it is available in green color, available in blue color, available in black color. But there very, because of limitations in production and quality problems with these cottons, people are not going. But some, now one of our ICAR institute come out with one variety that is called Vaidehi 95, which gives the very good properties of the fiber. And we have taken the very big demonstration in one of the agricultural universities in almost 100 acres, and we have developed the products, and very nice. What the jacket today we have weared is a completely naturally colored khaki jacket. It doesn't require any, it is not a single dye, synthetic dye has been used in this. So it is very good for the baby wear also. And now we can make the jackets, we can make the shawls, we can make the undergarments, and it is having a very niche market. In European countries, it is tremendous, and we are planning to take this project at a very high level. So this is our honorable minister also seeing these kind of products, and these are the our incubators which are now manufacturing the products, and they are selling to the international markets. So now this is absorbent cotton technology. This is also very good technology. Two entrepreneurs developed from by our institute, and almost then one we have given just as a representative names, one lady entrepreneur Apurva Bajaj, and apart from Apurva Bajaj, there are so many entrepreneurs have incubated from our institute, and they are manufacturing their own business. And you know, it is a medical textile, and it has almost 50,000 crore annual consumption of this kind of product, and it is having a very good export potential. And this is actually one of the product which gives the more value addition, even better than the garment making. So this is also one of the area we are working on that, and our institute has developed technology which have reduced so many steps of processing. So because of time paucity, it is not possible for me to give the complete details about the technology. But our technology intervention has led to the reduction of the cost of production of this absorbent cotton or surgical cotton. So these are again very much products that eco-friendly dyeing and finishing of khadi and handloom. That is also very good one technology our institute has developed and it is commercialized. Then the mosquito repellent sleeping bags. That is also it is import substitute for this product of the sleeping bags, which can be used by the police force in Naxalite areas as well as the some sports persons or those who are also going for the expeditions. This is very good product, and various other products also we have developed chemical free extraction of the essential oils. So it is, we are not only working on cotton, but we are also working on other peripheral areas like cotton fiber reinforced paper carry bag. Because of now plastic is also banned and it is not environment friendly, so we have come out with a very strong bag with fiber reinforced, which can last almost 1 month, and there is no problem with the bag. So these are some of the products. So we have linkages with the institutions, very good institutions like Hindustan Unilever, then BRC, then Bombay Stock Exchange, and all. I cannot give the names. Almost more than 50 memorandum of understanding we have signed during last just 4 or 5 years. So our almost we have signed 100 more about 100 memorandum of understanding. All are associated with us, and most of them are almost satisfied with our services. And we have a very big test house in our institute. Almost we are testing everything related to cotton and cotton oil. Almost 160 mechanical properties, then chemical properties, optical properties, all like very good instrumentation is available in our institute for testing the lint, yarn, fabric, seed, oil, linters, then comfort properties. Everything is being tested in our institute. So apart from that, because of our is the very big and premier institute, the Ministry of External Affairs has also given our project to us, that work in Uganda, Malawi, Benin, Chad, Nigeria, Burkina Faso under the technical assistance program for cotton, and our scientists to visit in these countries frequently and giving our Indian knowledge, indigenous technologies, and transferring to the these countries under through the Ministry of External Affairs, because these countries are helping in our United Nations for many issues, and they are voting for us. So this is our Government of India's initiative to give some funds to them and develop their cotton sector of these very poor countries of the Africa. So this is one, actually our institute have erected and commissioned one regional knowledge cluster from training center on post-harvest engineering technology in Boikon in Burkina Faso. So sorry, Benin. So this is the one photograph where I could see the barren land, and after 1 year, this is the structure we have erected, and bottom pictures are there, the machinery erected and commissioned by our institute in Benin, which is a French-speaking country. Western Africa. So this is our one of the very commendable achievement of our institute, making the proper physical infrastructure in countries in Africa. So this is our overall impact of CIRCOT technologies. We have so many technologies, almost reduction in the trash content leading to well value almost 2,500 crore rupees. Total impact. We are because of our interventions, government, our whole country is getting this cost addition, value addition. Then total impact of this institute's projects is around 3,140 crore rupees every year. So government of India is benefiting from our institute. So we are also celebrating 100 years in 2024, and we will be now planning to establish 3 center of excellences during coming 2-3 years. and it will be completed by when we are celebrating our 100th year. That is Modern Ginning System Excellence Center, then Center of Excellence for Cotton Classing System, and Center of Excellence for Nanotechnology in Agriculture. So it will be now. We have developed the complete master plan and submitted to the ICAR, and very soon it will be given to us. So this will be the one building also we will be making during this centenary year. So now my one colleague scientist will give you the nanotechnology aspects, because I can also present, but he will give the more justice to the subject, because he's working in this area since 10 to 12 years, and he is the expert in interministerial committees on nanotechnology. So I will be requesting my colleague, he will be so that our whole today's audience will be benefited from the nanotechnology point of view.
Yes, good evening, sir. Am I audible to the audience?
Yes, sir, you're audible.
Yes, so you're audible.
Okay, now I am starting the presentation. Myself is Dr. N Mishra. I am a principal scientist over here, working in the field of nanotechnology at CIRCOT for the past 15 years. So just I will be telling you some basics of the nanotechnology and what CIRCOT is doing on that to improve. So I think most of you people will be aware about this nanotechnology. It indicates the understanding and the manipulating of the material in the nanometer dimension, like 1 to 100 nanometer. And the history of nanotechnology, it started in the year 1959, when the scientist Richard Feynman, in his talk, it is about there's a plenty of room at this bottom. So he focused, he envisaged that the top-down approach of nanotechnology will come in the future. But the actual term of nanotechnology was given by the scientist Norio Taniguchi in the year 1974 in his publication.
Can you share your screen? Excuse me. Please,
Oh, yes,
please.
sir.
Sir, share your slides, how Professor G Patil shared. Can you share? Thank you, sir.
Is it visible now?
Yes, it is fine. It is fine.
So this nanotechnology is about understanding and manipulating of any of the material at this nanometer dimension to 1 to 100 nanometer dimension. And about the history of nanotechnology, the Richard Feynman in his top-down approach, he focused on the nanotechnology, and he told there's plenty of room at this bottom. And the term nanotechnology was introduced in the year 1974 by the scientist Norio Taniguchi. And it was followed by the major thrust to the nanotechnology came after the invention of AFM, that is the atomic force microscopy. It was invented in the year 1986 by three scientists, Binning, Quart, and Gerber. So after that, a lot of thrust has come on this nanotechnology, and it was followed by this invention of carbon nanotubes by the scientist Sumio Ejima in the year 1991. So these are all those major type of milestones what we have experienced in the field of nanotechnology. After all these inventions, there is a huge amount of increase in the basic studies and applications of nanotechnology in various fields, diversified field. And one among them is the textile industries, followed by this medical pharma industries and composite. So many fields got impacted due to this intervention of this nanotechnology. So I think all of you will be aware how this nanotechnology is important, why the size does matter. If you are considering any of this material and without changing its composition, simply you are again reducing the size alone. You can see how the number of particles and the surface area is increasing. I am starting with the one big cube of dimension 1 meter dimension. We are having one particle, the surface area is 6 square meter. And if it is reduced to 3 times of the dimension, then the number of particles is increasing exponentially. And still further size is reduced down to this micrometer and to this nanometer. You see the number of the particles and the amount of the surface area exposed, it increases exponentially. So it indicates that without adding much of this material, only with the available amount of this material, you can have enough number of particles or a huge amount of the surface area. It will be of very much helpful in case you are focusing on catalysis, or in case of composite for the surface interaction, wherever the surface area is important. And in that case, this nanomaterial will be having a huge impact. So what are the advantages of size reduction? You will be aware how this mobile phone is helpful. After this integration of your computers and phone, camera, and apart from that, so many of these applications can be confined into a single of this mobile phone, and it helps us in space saving, energy efficient, multifunctional, and convenience. So it is one of the practical type of applications what we are facing now. So why this nanomaterial or this nanotechnology is important? Here, with the help of nanotechnology, we can achieve novel and different type of attributes, and that too size dependent. Without changing the chemical composition of this material, we can have different attributes. For example, the first one is the surface plasma resonance. This type of property is available in case of these metals. When the metal size is reduced, you can see when it is going to this nano size range, in case of the platinum or gold or silver, if it is achieving this nano size, you can see there is a lot of change in its color. Otherwise, gold is yellow in color, but if it is nano size, it can be of pink or it can be of violet according to the size. It is called as the surface plasma resonance. And in case of the semiconductor, the parameter is called as quantum confinement effect. Semiconductor like silica or silicon or this magnesium oxide, it will be having a particular amount of this band gap. But once the size is reduced, the band gap will be increasing. So if you want to go for the band gap engineering, you can just reduce the size without changing this material composition. It's a huge advantage in case of semiconductor industries. And then the third property, surface area, that we are aware it is applicable in case of all the type of materials. And similarly, in case of this enhanced mechanical attributes, and further with the case of catalysis, superparamagnetism, and conductivity and thermal attributes. So various attributes are affected according to the size of this material. So based on our type of application required, we have to find out which is suitable for our application. And this nanomaterial is also classified according to its composition. It can be of these metallic particles or of metal oxide particles, ceramics, polymers, and carbon. So according to the type of these materials, or according to the type of attribute required for our application, we have to choose the type of this material and convert into its nanoform, then we can apply it. And another type of classification is based on its dimension. We are having 3 type of classification. One is the of the 0 dimension, and another one is 1 dimension, another one is the 2 dimension. So the first category comprises of these nanoparticles, nanocube, nanospheres, where all the 3 dimensions are confined in the nanometer regime. And in case of this 1 dimension, it is examples are of these nanotubes, nano rods, and wires, where only 2 dimensions are confined in the nano, and the 3rd dimension can be of any size. It can be of lengthy one. And the 3rd classification is the 2-dimensional, where the only 1 dimension is confined to this nanometer, and the other 2 may be of any size, like in case of thin films, graphene, and self-assembled mono layers. So if you want to synthesize any of these nanomaterials, there are 2 major approaches, like top-down approach and bottom-up approach. In case of the top-down approach, we are starting with the bulk material. You are taking a bigger particle and applying a lot of energy into the system, then reducing the size to this micron size, then down to the nano size. So once the size is entering into this nano regime, the property gets changed entirely. And in this case, advantage is that this type of process is amenable for the commercial or the industrial scale application, like high energy ball mill, planetary mill, then high pressure homogenizer, different type of reactors are being used, and its yield is also very high. But the problem we are facing is that it requires a lot of energy, huge amount of energy is required in this process. And another one is the bottom-up approach. In bottom-up approach, we are starting with the atoms or ions. So the thing what we have to understand is that these atoms and ions are again smaller than the nanoparticle. So we are starting with the atoms, molecules or ions, then we are trying to aggregate it or agglomerate it. Then it forms this nanoparticle. And here it can be done by the chemical process, electrospinning, or this microbial process. And here advantage is that the size distribution of the final product will be very much uniform. But the problem is that in this case, yield will be quite low compared to the top-down approach. So each and every type of approach is having its own pros and cons. According to our type of requirement, we have to finalize it. Then this nanomaterial can be synthesized by the physical, mechanical means or chemical means or the biological means. Various options are available. And if you're going for the characterization of these nanomaterials, any type of characterization tools can be of useful. But the two typical thing is that one is the for size analysis. In case of DLS analysis, it is called as dynamic light scattering analysis. And for the in case of this morphological analysis, AIFM, that is the atomic force microscope. These two things are of typical to this nanotechnology. Apart from that, all other tools like SEM, TEM, SAX, fluorescence, any type of the tools can be of useful in analyzing the nanomaterials. So coming to our type of work, what we have done. So this is the type of work we have done 10 years back, where these microorganisms were used for the synthesis of nanoparticle, synthesis of silver particle. If you want to synthesize any of the silver particle, it's quite simple, very straightforward. You take a silver salt and add it with some of those reducing agent and the type of capping agent, you can get this nanoparticle by any type of chemical process. But we are focused by this microbial process to have some amount of eco-friendliness with that. Here, some of these microorganisms having some type of reductase enzyme, it will help in case of synthesis of silver nanoparticle. And what you are seeing here is the transmission electron micrograph of the silver nanoparticle, what we have synthesized. So these silver nanoparticles synthesized, we have tested its efficacy, like antibacterial activity, against two standard pathogens like Staphylococcus aureus and Klebsiella and pneumonia. What you are again seeing is the Petri plate, and it is loaded with the those pathogenic organisms, and the zone clearing zone, and the clearing zone happened due to the nanosilver. So with increasing in concentration, the clearing zone is bigger. Then this nanosilver is applied onto the cotton fabric, and here the photograph you can see as control is the white cotton fabric, and all other fabrics are having some amount of color. So those fabrics are treated with the nano silver. Here advantage is that this nanosilver is having antibacterial activity also. Apart from that, it is having its own type of color. So according to the amount of silver applied, the intensity of the color is very much darker. So it's giving two types of functional attribute to the fabric. And as director told already, this type of technology is being used in one of these commercial type of product. It's a athleisure. And apart from that silver and nanoparticle, we have worked on the zinc oxide also. In some cases, we don't like to have the type of those colors coming from the silver, and also silver is a bit costly compared to the zinc oxide. So we have focused on the zinc oxide. Zinc oxide is completely of white in color, and if it is nano, it will be almost transparent. And here, zinc oxide is having two attributes. One is it is also having some amount of antibacterial activity. And the second thing is that since it is a type of semiconductor, it is having its band gap. So it can absorb this ultraviolet light that is coming out of the sun rays. So we have synthesized this nano zinc oxide and applied on the cotton fabric, and that is being used as the surgical gowns and bedsheets. And here we can see the scanning electron micrograph of this control cotton fabric, and the cotton fabric loaded with this bulk zinc oxide and this nano zinc oxide. And the second row shows the antibacterial activity against those pathogenic microorganisms. And first and second we could not see, and the third row where it is coated with this nano zinc oxide, you can see the antibacterial activity of the cotton fabric. And similarly, the same type of nano zinc oxide was coated on the surface of this paper, and it was tested for the antifungal activity. Because paper coating is very much required if you want to archive any of those books and storing for quite long time. I mean, it's not affect. So here also we can see this nano zinc oxide coated paper is very much tolerant to the aspergillus fungus. And simultaneously, this nano zinc, what we have developed, we have tried for the field application. Since ours is an agricultural institute, we focused on the agricultural application also. So this nano zinc oxide, what we have prepared, was tried for its effect on the brinjal plant. And zinc is a essential micronutrient. It is very much required. So this nano fertilizer applied in brinjal field, it shows very much increased yield and its biomass compared to the control. And this technology was transferred last year to the RCF. This is Rashtriya Chemicals and Fertilizers Limited. And that zinc oxide technology was used in case of sleeping bag also. The sleeping bag is used by the soldiers, police at remote places. So that time that in case of commercially available sleeping bags are of synthetic fabrics, so it will be highly uncomfort. So we want to introduce some amount of the cotton inside the sleeping bags, and so that cotton has to be coated with some amount of antibacterial activity. Otherwise, it will be smelling if it is used continuously. So for that purpose, we have coated with the zinc oxide also. And another important aspect of our focus of research is nanocellulose. All you will be aware about cellulose. So cellulose is a combination of crystalline region and amorphous region. And at the time of its processing, when this amorphous region is removed, what we will be achieving is finally of crystalline region alone. And here all these amorphous region get removed. So what we are achieving is nanocellulose out of cellulose. So since amorphous region is removed over here, the final material will be having huge amount of strength. Its mechanical attribute gets increased in case of nanocellulose. And this is the structure of the cotton fiber and how the cellulosic fiber is extracted and how this nanocellulose gets formed. And so ICAR CIRCOT, we have developed our own type of this production sequence. We are starting from the waste cotton. We don't use this good quality cotton. We always start with this waste cotton. It is purified to get the purified form of cellulose. And then some amount of the pre-treatment is required. Some amount of chemical treatment will be done. Then finally, it will be subjected to the high pressure homogenization, where you'll be getting nanocellulose. So this technology is our own technology, and we have optimized to have the optimum amount of energy consumption and a huge amount of yield. So we can see the photograph of the cotton fiber, how it looks, and after the processing, final processing, how this nanocellulose looks. And due to the size of this of nanocellulose, it is always in suspended form. It's not settling. And some of these AFM image, that is the atomic force microscopic image of this nanocellulose, it is viscous shaped, and the another one is the spherical shaped. So this AFM image advantage in case of nanotechnology is that we can get the 3D image compared to any other image like AF means SEM and TEM. We are getting is a type of 2D image. But here we can see the x-axis, y-axis, and then z-axis also. And as I told you, since the amorphous region of nanocellulose is removed, the strength is very much comparable to steel and aluminum wire. Here, the tensile strength and its modulus is compared with various material like glass fiber, aluminum, wire, and steel. And this cellulose crystal, that is called as nanocellulose, is very much higher than all these things, but it is comparable with this graphite viscous and these nanotubes of carbon. So this was our nanocellulose pilot plant. Generally, this nanocellulose is produced in grams quantity at this lab, but it cannot be tested by any of this industry. So to increase our productivity, we have started this nanocellulose pilot plant. It was inaugurated in 2015 by Padma Vibhushan Dr. R.A. Maselkar, and it is the inside view of this nanocellulose pilot plant, how it looks. And so this our nanocellulose pilot plant is one among the various pilot plant available all over this world, and it was reported in the TAPIS report in 2015. And we are having 3 different types of patterns. What is implemented in our pilot plant? We are having the microbial process, chemomechanical, and enzymatic. It's a type of combination of various processes we are using in our pilot plant. And application of this nanocellulose comes in food industries. So, generally for the food packaging, the starch film we are trying to use, but the starch film, the strength is not sufficient when compared to the polyethylene and all. So, to improve the strength, this nanocellulose is added, and even less amount of nanocellulose, 1% is enough to improve the strength. Here we have taken a lot of trial for packing of the strawberry, and broccoli. And advantage is that it is degradable and the strength is improved 3 times, and oxygen permeability is also get reduced to 2 times. So the shelf life of this packed material, it gets increased. And similarly, in case of the starch-based film, like a starch PVA film, this nanocellulose is added as the filler, and it can be even used to pack the oil. So very good type of packaging film we can make, and we can see the film is used for storing the chips and oils. The oil, such it will not get leak out, since the starch film is highly hydrophilic, but the oil is as such it's not compatible with that. So it gets packed well. So this nanocellulose pilot pen, we are supplying this nanocellulose as a type of sample, research sample, to various industries for the development of new or different types of products. And another important aspect of this activity is this nano fiber. So for the nanofiber, all of you may be aware that electro spinning is the type of system what is used. So here we are using high voltage system along with this polymer. The polymer will be converted into the nanofiber. But here we are having a different types of collector. Our own indigenous different type of collector is made, and out of this we are preparing this nanofiber. So some of the ACM image of this nanofiber. And another the important invention is about this nanofiber coated yarn. Here you can see this is the cross-sectional view of a filament, and here at the center is the synthetic filament. It is coated with the cotton nanofiber, cellulosic nanofiber. So this can be used as the switches. And apart from that, CIRCOT is participating in the development of guidelines and best practices for this nanotechnology. We are participating in DST and DPT also. We have developed already 2 different types of protocols for this. So overall activities are a few more activities. This nanocellulose infused face mask is under development, and some of the hydrophobic fabric also we are trying to synthesize with the help of nanoform of the silica, and then self-cleaning fabric with the help of titania. So the titania is having a type of photocatalytic activity. In its nanoform, it is applied onto the fabric so that it can be having self-cleaning activity. And zinc oxide, as I told you, if it is coated on the fabric, it will be absorbing this UV light that is coming out of the sun. And then cellulose reinforced starch packaging for the food application. And then copper in its nanoform is a very good antifungal agent that we are also trying. So apart from all this type of research work, we are having huge amount of the facilities, whatever is required for this nanotechnology and microbial synthesis of nano in our lab, like AFM fermenter, membrane reactor, chromatography, homogenizer, and high energy ball mill, DLS particle size analyzer, XRD, Raman spectroscopy, ultracentrifuge, and mass collider and freezer, and so many other facilities are there. So apart from these R&D facilities, we are organizing various types of training, and then commercial samples also we are testing in our lab. So another important aspect is that if this nanomaterial is released into this environment, if you are applying onto the fabric after it gets used up, if you are throwing out, where it goes, it can enter anywhere. It can enter the water, soil, atmosphere, plants, microbes, anywhere it can enter. So we have to focus on the safety aspect also. So for that, various international standards are available, like ISO standard, ASTM standard. Various standards are available of these days, how to arrange for the safety aspect at the time of handling, at the time of use, and at the time of disposal. And our institute approach is that first thing is the safe handling and the safe disposal, and then we are focusing more on this of nanoform of cellulose and starch, since all are organic. We don't focus on the nanotubes of carbon and the other thing we don't use. We focus more on these organics and its nanoform, their application. And then fourth aspect is that consumer awareness. Who is going to use that one, we have to inform them. Truthful labeling should be there. Then afterwards, need-based use of nano. Wherever is required, only we should use this nano. It should not be used in other places. And then we are going for the toxicological analysis with the help of AI, artificial intelligence and machine learning. So as all of you will be aware, there is a huge scope for this global nanotechnology, and by 2020 and 2027, and it's going to increase in the long run. So for that, we have to work on this nanotechnology in a reasonable way. Thank you for hearing.
Yes. Thank you. Thank you. It was a wonderful presentation. In fact, for a food technologist and food scientist, it is a very, very informative. In fact, I didn't know so much about the cotton and how, and in the latter part, nanotechnology, which he presented, lot of application it has in food processing area. I saw that in the chat box, a few of the answers are posed, but most of these answers are already, questions were posed, but many of these questions are already answered during this presentation on this nano. So we have a very good in-depth. I think Jayashree might have some questions, so you can give.
Thank you, sir, for such an amazing presentation. Like we didn't thought it could be so colorful. And the innovation and the technology have reached so many people. Without your presentation, we wouldn't have known that how CIRCOT have got from very ground level, and it has reached to such a level that the products are being marketed in Amazon. So we have a few questions people have asked. Mr. Prakash Kumar have asked, what is the potential toxicity assessment of NP's application in agri-food system? Whatever the nanoparticles which you have used, what are the potential toxicity assessments I think, Professor?
Yes.
Sir, about the toxicity, in case of the cellulose and starch type of nanoparticle, there is not much of toxicity. But in case of the zinc oxide and all, we are analyzing that one. So we are having separate type of project activities going on to understand the toxicity. And zinc, already it is being used as a type of the fertilizer. So we are envisaging that there will not be much to that one. Yes, we don't add any of the toxic chemical into the system. We simply add some type of organics as a type of stabilizing agent, like the starch and cellulose is added to the zinc as a stabilizer. So it may not add to the toxicity, but still the analysis is going on.
Sir, I think already you have mentioned in your presentation, but people were still asking. I will just ask you to answer in a very simplistic manner to you and Professor Patil. People were concerned about the antimicrobial properties, or how can some gaskets or some cotton parts could be made for food manufacturing industry. Like, are you planning for that? Like some antimicrobial technology which could be used for food manufacturing or food industry from cotton fiber which you have developing? A very simple answer. People were like, I am getting current answers from questions from people. Any antimicrobial thing from cotton which could be used from food industries?
Yes,
like
as of now, we don't have so much focus on the food industry. Only we are focusing on the packaging application. In case of the packaging films, we do add the nano form of the cellulose, and for the antibacterial activity, we add the chitosan. And so chitosan is having very good antibacterial activity. It can be added with the packaging films, and then it can be used.
Yeah, that was exactly the question. I think that's why I told you have already answered that antibacterial.
That's why, yeah.
Materials which can be coated in the interior of the packaging materials, etc. So that you have presented during your presentation.
Sir, there is a question, very simple question from Professor Dhulipala Babu for Professor Patil. He asked, is CIRCOT Mumbai providing training on cotton processing and machineries? They might have a query.
Yes. Our industry is organizing various type of training program. You can approach us.
So we will be like concluding this lecture now. Whatever queries and questions we have, I will request. Yes,
Before
sir.
concluding, you can just, if there is any, you can give, if Dr. Patil agrees, so you can give some questions, particularly the students, etc., which are there. If anyone want to ask a direct question, one or two, you can. If, of course, if Dr. Patil agrees.
Yes, sir. No problem, sir.
Definitely, anyone can just on your video and audio, and they can ask question. We can have, and for further queries, we will share Professor's
to students, and then we can other solutions. Because this is
yes,
a opportunity for everybody.
yes,
Yes.
yes, sir.
Does anyone have any question? You can
Someone has asked about the, I think Geeta ma'am has asked about the antiviral experiments of nano cotton, and someone, and one more
she was
people has
asking anti-corona mask. Mask which can, what is that is able to protect coronavirus or not? I think that was the question, Geeta.
Yes, sir. Yes, sir. Correct, sir. It'll be a huge, it has a huge potential if at all the results are positive, because PP with if the PPEs are replaced with a breathable material,
Yeah.
I think it will be helpful even for any kind of future pandemics as well. I don't think this is the last one we will be facing.
very true, ma'am. Very true.
Even the mask which we are wearing, we are
Yes,
having
sir.
so many information that is it is not fully protective.
Correct. So if it is cotton, it makes breathing ability of the cotton material will help in both masks as well as PPE, especially for the doctors and everyone.
That when the people ask questions, something was coming to my mind also, that is good for thought to Dr. Patil. He has such a good infrastructure there in his institute and a good team, excellent team. So can we cotton?
We have taken the project on manufacturing of PPE.
Yes.
And very soon the product will come out.
Yes, that's right. So
that's a great news, sir.
Dr. Patil, can you think of that is I don't know, you may tell better, replacing this even jute or the plastic, etc., with the suitably developed cotton material for food packaging, food transportation, etc. So that will, I don't know what will be the economics and other things, but if it is done, it may be really a wonderful contribution, because the plastic, etc., environment pollution and its degradation, etc., is a problem. So cotton may be a better, I don't know.
You are correct, sir. That's why actually I have made the divided into presentation into two parts. That is one general, because the being a director, he has to play a very balanced role.
That's right.
We have to give some importance for the industry as well as the farmers. Apart from that, we have to take the very frontier research also. So we have a very good some team is working on frontier research, some team is working on some conventional research, then value addition for farmers' point of view. So being a public funded institution, we have to, and that doing under ICAR, Indian Council of Agriculture Research. So we have to do a very balancing role. And sir, you are also aware, we have only 25 scientists in my institute. And sanction strength is 50. So, and there is no recruitment is being taken place. And for your information, minimum qualification for becoming scientist, they have made as a PhD.
Yes.
So, PhD in textile and that to engineering, very few people are coming. So, I do not know what will happen to the institute, but we have to run the show. Show must go on. So, and I am very happy that our team is very young team. I think average age of this 25 scientists is around less than 40.
Yes, that's good. But that's
Yes,
good.
So this team is very motivated. We are doing, but we are doing against all odds. Our tempo is very high, and we are working on this. And let us see.
Sir,
Sir, may I please interrupt? Correct me if I'm wrong.
ask a question.
Can you hear?
I know
Sir?
after Gita.
Yes, sir.
Then after
I'm just curious. So the material after this nano cotton which you are telling, that particular material can be supplied to the virological institutes and can be tested for efficacy there. So I know virological institutes are the only institutes where proper lab facilities are available to test such things. So your samples can be provided to those institutes, and once it is approved, then only product
Gita, they will be definitely taking their. Take it. I think they will be definitely. Yeah.
because experiments cannot be conducted by the institute itself.
Yes.
Thank you, sir. Thank you.
Thank you, Gita ma'am. I will take next question from Indira.
Indira wants to. Hi, Indira Depal.
Sir, actually, I wanted to ask that how are you? Yes, sir. Yes, sir. Can you hear me?
Yes.
Sir, I wanted to ask that how are you using these nanomaterials? Are those in the form of nano rods or nano wires?
No, ours 2-3
In
types
cotton?
of that. In case of the silver and zinc oxide, it is almost spherical in shape. But in case of the cellulose, it will be of viscous.
Okay.
It's that small size rod shape. Viscous.
Okay, sir. Okay. Thank you, sir. Thank you.
Jay